At the very center of our galaxy, hidden behind veils of dust and silence, lies something so heavy it bends the paths of stars, yet so invisible it might as well be a secret carved into the fabric of space itself. Imagine it for a moment, a presence that cannot be touched, cannot be seen, yet moves entire suns as if they were no more than drifting sparks. This is the mystery at the heart of the Milky Way, the mystery known as Sagittarius A. Every galaxy tells a story, and every story has a guiding thread. The tale of the Milky Way, the sprawling island of stars we call home, is not simply the sum of billions of suns, planets, and drifting clouds of dust. It has a center, a quiet axis around which everything turns. And though this center is dark, though it hides itself behind curtains of gas and shadow, it is the anchor of our cosmic family. Without it, the Milky Way would not be what it is. Now, if you step outside on a clear night and tilt your head back, you will see a streak across the sky. The ancient ones called it the River of Heaven, or the Path of Souls. To us, it is the Milky Way, a silvery haze made of countless stars so far away that they blur into a single glowing band. Somewhere in that vast stripe of light in the constellation Sagittarius lies a place that few can truly picture. 26,000 light years from Earth, far beyond anything we could hope to visit, rests a black hole. Not a small one, not the kind born from the death of a single star, but a giant. 4 million times the mass of our sun, compressed into a darkness so complete that even light itself cannot escape. It is hard to imagine such a thing, hard to let the mind rest upon it without drifting into wonder or unease. 4 million suns, gathered together, pressed into a silence smaller than the orbit of Mercury. If our sun were to vanish into such an abyss, it would be swallowed whole without even a flicker. And yet this vast object, this unimaginable weight, does not rage. It does not call attention to itself. It waits, patient, hidden behind clouds of interstellar dust that make direct sight impossible. We know it not by what it shows, but by what it compels. There is something profoundly unsettling in that. To live inside a galaxy held together by an invisible hand, to orbit unknowingly around an unseen heart, is to realize just how much of reality remains concealed from ordinary sight. Yet there is beauty in it too, a kind of quiet majesty. For what greater mystery could a galaxy carry than to cradle such a being in its core? Sagittarius A is both secret and sovereign, both veiled and commanding. It is the unseen monarch of the Milky Way, shaping the orbits of stars across tens of thousands of light years, while itself remaining cloaked in silence. Pause for a moment. Picture it not as a cold calculation, but as a living presence. Imagine that you are drifting through space, past glowing nebulae and swarms of stars, moving inward toward the dense, crowded center of the galaxy. The further you travel, the thicker the stars become, until the sky is ablaze with light. Suns are packed so tightly they would outshine any night sky you have ever known. And in the deepest heart of that brightness lies the opposite of light, a circle of absence, a black hole. It is not visible, and yet its influence is everywhere. Stars whip around it at incredible speeds, their lives dictated by a darkness they cannot resist. This is the paradox of Sagittarius A. It is the most influential object in the galaxy, yet also the most hidden. The brightest stars near the center bow to its pull, but the black hole itself gives off almost nothing. It is like the silent director of a play, never stepping on stage, but orchestrating the motion of every performer. Without it, the show would collapse. With it, the dance of stars continues. To many, the thought of a black hole at the core of our galaxy is frightening. It feels like a danger, a lurking predator, one that could one day awaken and consume. But distance grants us comfort. At 26,000 light years away, Sagittarius A is far enough that Earth is in no immediate danger. It does not threaten our sun, nor does it hunger in our direction. In truth, its role is not so much of a devourer, but of a stabilizer, a weight that balances the Milky Way, keeping the structure of the galaxy coherent, steady, bound together. But here is the strange, almost poetic part. For most of human history, no one knew it was there. The black hole remained hidden from eyes and instruments alike, buried under cosmic dust. We saw the Milky Way's central bulge, we charted the stars, but the true heart of the galaxy was invisible. Only in recent decades did astronomers begin to uncover the secret. Watching the way stars at the center raced in tight, frantic loops, pulled by something that could not be seen, It was like finding footprints in the sand without ever seeing the walker. The more closely we looked, the more undeniable the conclusion became. There was something vast and dark there, something that could only be a black hole. And so the hidden heart of the Milky Way revealed itself, not by shining, but by pulling, not by light, but by gravity. What a strange idea that is. The most powerful object in our galaxy declares itself not with brilliance, but with silence, not with fire, but with absence. Think of what that means. A black hole is not an object in the usual sense. It is not a star, not a planet, not even a piece of matter in the way we normally imagine matter. It is space itself, bent inward, a pocket of reality where the rules we rely on cease to function. Sagittarius A is a kind of scar, a wound in space-time, where the familiar becomes unknowable. And yet, it is this wound that holds our galaxy together, this silence that provides structure to the Milky Way's story. It is unsettling, yes, but also beautiful. For in Sagittarius A, we see the paradox of the universe, that absence can be presence, that darkness can guide light, that what is hidden can still define everything. And so, as you lie back and listen, imagine our galaxy turning, slowly and silently, held in the embrace of an invisible giant. Imagine that quiet center, waiting, veiled, yet eternal. But here is the question that leads us forward. If it cannot be seen, if it hides behind both dust and darkness, how can we be so sure it is there at all? How do we know the heart of the Milky Way truly contains such a strange and secret presence? The proof came not from light, but from motion. In a universe where almost everything we know comes from light, that fact alone feels extraordinary. We study the cosmos by collecting the glow of stars, the radiation of gas clouds, the faint whispers of galaxies so distant their light has been traveling toward us for billions of years. But the evidence for Sagittarius A did not arrive on a beam of light. It came through gravity's choreography, through the movement of stars caught in a dance so strange that it revealed the hidden conductor at the galaxy's center. For centuries, the core of the Milky Way remained an impenetrable mystery. Clouds of interstellar dust blocked our view, smothering visible light before it could reach Earth. Even the strongest telescopes could not pierce the veil. The galactic center was a blank spot, a place we could only imagine. Some believed there might be a cluster of stars there. Others speculated about exotic objects, but the truth was obscured. Then, as technology advanced, astronomers began to look not with ordinary eyes, but with new ones. Infrared telescopes and radio observatories gave us the power to see through the dust. What they found was astonishing. A tight cluster of stars, each one luminous, each one moving at breakneck speed, whirled around a point of space that appeared empty. Imagine stars larger than the sun, rushing through space faster than any planet in our solar system, moving in orbits so close and so extreme that they seemed impossible. It was as if a crowd of fireflies circled around a patch of pure darkness, never colliding, but never straying from their invisible anchor. The closer astronomers looked, the more undeniable the conclusion became. Something massive sat at the center of those orbits. Something so heavy that it forced stars many times the size of the sun to slingshot around it like stones tied to invisible strings. Yet when astronomers pointed their telescopes directly at that point, they saw nothing. No blazing star, no glowing cloud, no cluster of matter bright enough to explain such power. The stars were moving around emptiness. And that emptiness had weight. One star in particular, known as S2, became a key witness. S2 is a bright blue giant, and every 16 years, it traces an elongated oval around the galactic center. At its closest approach, it swoops in so near that it travels at over 7,000 kilometers per second. Imagine that. A star, millions of times heavier than Earth, hurtling through space at speeds that make our spacecraft look like crawling insects. And yet, S2 does not fly away into space. It is tethered by something, compelled by a gravitational grip too strong to resist. When scientists calculated the mass needed to hold S2 on its course, the numbers were staggering. 4 million times the mass of the Sun, compressed into a region smaller than the solar system. No known cluster of stars could account for such density. No ordinary object could exist there. The only explanation was a supermassive black hole. This was not a guess, nor a leap of imagination. It was the most direct evidence possible, short of actually seeing the black hole itself. The stars were the proof. They were the leaves caught in a whirlpool that remained unseen. By studying their orbits, astronomers were able to map the presence of something that could not be touched or observed in any other way. It was as if the universe had signed its name in the movement of stars. Take a moment to picture this. Imagine you are watching a flock of birds circling in the sky. There is no tree, no mountain peak, no visible landmark to explain why they keep returning to the same point. And yet, again and again, they wheel and turn, held by something unseen. You cannot see the center, but you know it must exist. That is how astronomers felt when they traced the paths of S2 and its companions. The invisible was undeniable. There is something profoundly moving in this realization. Humanity, tiny and fragile, standing on a small planet 26,000 light-years away, was able to detect the presence of a supermassive black hole not by touching it, not by seeing it, but by noticing how stars bowed to its will. It was an act of extraordinary patience, watching these celestial dancers move slowly year after year, waiting for them to complete their steps, charting every flicker of their light, and finally declaring with certainty that we were watching the influence of a giant in the dark. And here lies a quiet irony. The black hole itself is utterly invisible. It emits no light of its own, no signal that could betray its presence. It hides in silence. Yet in hiding, it forces everything around it into motion. Its very invisibility becomes proof, because without it, the dance could not exist. The stars are its witnesses, their orbits its testimony. They speak on its behalf, even as it remains mute. Consider how strange that is. The universe often reveals itself through brilliance. Stars shine, galaxies blaze, quasars erupt with light that can be seen across billions of light years. But Sagittarius A revealed itself through absence, through the way light-bearing stars curved around a darkness. It is like discovering the existence of wind not by seeing it directly, but by watching trees bend in unison. The hidden shapes the visible, the silence gives meaning to the song. For astronomers, this was more than just confirmation of a theory. It was a triumph of human curiosity and perseverance. To measure the orbit of a single star across 16 years requires extraordinary patience. Generations of astronomers devoted their lives to this effort, handing their observations forward like torches in the dark. And when the conclusion finally emerged, it was overwhelming. The Milky Way, our galaxy, our home, is anchored by a supermassive black hole. In this way, the dancing stars at the galactic center became storytellers. They whispered a truth across the void of space, a truth that our instruments captured and our minds unfolded. Their orbits told us that the universe hides giants, that absence is not emptiness, and that even the darkest places shape reality in ways we cannot ignore. Pause and let that sink in. Every time you look up at the Milky Way, every time you trace that glowing river across the night sky, remember that at its center stars are racing, circling, bowing to a force beyond sight. Their very existence depends on it, and so does ours, for without Sagittarius A, the structure of the galaxy itself might unravel. And yet, this whirlpool does not rage like the black holes we read about in distant galaxies. It does not roar with jets of light or gorge itself on endless matter. It waits quietly, almost humbly, at the center of everything. In most galaxies, the centers blaze with violence. Supermassive black holes feed on torrents of gas and stars, pulling matter into swirling disks that glow brighter than entire galaxies. These objects, called quasars, shine across billions of light years, their light outpacing the brilliance of trillions of suns. They are ferocious, insatiable, radiant with destruction. Yet at the heart of our own Milky Way, the story is different. Sagittarius A is quiet. It is not absent, not powerless, but restrained, almost reluctant to reveal itself. Unlike its ravenous cousins scattered across the universe, our black hole consumes very little. To call it quiet is not to say it is small. It is immense, 4 million solar masses folded into a space so compact it warps reality. But its appetite is strangely meager. Where other black holes tear apart stars and swallow endless rivers of gas, Sagittarius A nibbles at scraps. Clouds of interstellar matter drift past, yet only fragments ever fall inside. For most of its life, it remains dormant, as if it is a sleeping giant uninterested in the banquet all around it. Astronomers often marvel at this contrast. In distant galaxies, we see supermassive black holes blazing so brightly they outshine every star combined, their jets spearing across space for thousands of light years. Those are black holes in the prime of their hunger. Sagittarius A, by comparison, glimmers faintly, releasing only the occasional whisper of energy. It is like a king who refuses to sit at the feast, preferring silence in his hall while others gorge in noisy celebration. Part of the answer lies in its environment. The Milky Way's central regions are rich in stars, but the gas supply that black holes crave is relatively thin. Most of the time, there is little for Sagittarius A to swallow. Another part lies in the complexity of feeding itself. Matter must fall inward, shedding angular momentum, spiraling down through invisible gates before it can be consumed. Often, material simply orbits and drifts away, never crossing the fatal threshold. So the black hole waits, patient, consuming less in a million years than some quasars devour in a single day. This calmness brings a strange comfort. For us here on Earth, the quiet nature of Sagittarius A makes the galaxy feel safer. A raging quasar at the center of the Milky Way might have flooded space with radiation, destabilizing the fragile chemistry of life. Instead, our black hole is subdued, almost courteous in its restraint. It allows the Milky Way to remain a home, a place where life could emerge in distant spirals and arms, unthreatened by the furious hunger of the core. Yet calmness does not mean simplicity. In fact, it makes Sagittarius A more mysterious. Astronomers puzzle over this, for black holes are thought to grow by feeding, and yet our own seems content to rest. Perhaps it once was more active long ago, when the Milky Way was younger and richer in gas. Perhaps it will awaken again should a dense cloud wander too near. Or perhaps it will remain a slumbering monarch for eons, leaving its court of stars to dance around it in peace. Consider what this restraint means for our imagination. We picture black holes as devouring monsters, endlessly swallowing, endlessly destroying. Yet Sagittarius A reveals a different possibility. It is not a constant predator, but a sleeper, an anchor, a presence that exists without perpetual violence. It bends time and space, yet it does not scream for attention. In its quietness, it reminds us that power does not always announce itself with spectacle. Sometimes the greatest forces whisper rather than roar. Still, even whispers can carry weight. Astronomers have observed faint flickers, tiny bursts of light from Sagittarius A as matter occasionally brushes too close. These are not the mighty jets of quasars, but smaller flares, brief outbursts that vanish as quickly as they come. And when they appear, they remind us that the black hole is not entirely asleep. It is watching, waiting, capable of awakening in moments of hunger. There is something unsettling in that thought. To imagine a being of such immensity lying dormant, ignoring most of what drifts past, but ready to ignite, should something fall into its grasp. It is like a volcano slumbering beneath a quiet meadow. The grass grows green, the flowers bloom, but beneath it all is a reservoir of molten power, hidden, restrained, yet never gone. The quietness is not weakness. It is potential. And so Sagittarius A stands apart from its cousins across the universe. While some black holes blaze with fury, ours watches in silence. While others devour, ours drifts into patient hunger. It is not absent, but reserved, a paradox at the heart of the Milky Way. Less threatening, perhaps, but more enigmatic. For what is stranger, the monster that screams, or the one that waits? Pause and reflect on this. If you were drifting near the galactic center, surrounded by stars brighter and denser than anything in our skies, you would not see a raging beacon. You would see movement, gravity's pull, and perhaps, now and then, a flicker of energy. The rest would be silence. The greatest force in the galaxy would stand before you, cloaked in stillness, veiled in patience. This is the essence of Sagittarius A, a quiet giant, too heavy to ignore, too hidden to behold. It shapes the Milky Way without constant display, guides the stars without drawing attention, holds our galaxy together without demanding recognition. It is both absent and present, invisible yet undeniable, a paradox that deepens the mystery of existence itself. And though we might find comfort in its restraint, we should not forget that restraint does not mean permanence. Silence can break. Hunger can awaken. The quiet giant may not feast often, but when it does, even the galaxy feels it. Silence, no matter how deep, does not last forever. Sometimes it trembles, sometimes it cracks, and sometimes it erupts with sudden violence. At the heart of the Milky Way, Sagittarius A spends most of its existence cloaked in stillness. It is the quiet giant, patient and restrained. But every so often, that quietness breaks. A fragment of gas wanders too close, or a wayward star drifts into the danger zone, and then the darkness awakens. When Sagittarius A feeds, even briefly, the result is extraordinary. Matter that approaches the black hole does not fall in quietly. It is stretched, twisted, heated to millions of degrees. The atoms scream as they spiral inward, releasing energy in the form of powerful radiation. For a moment, the black hole blazes, not with its own light, but with the light of matter being destroyed. Astronomers watching the galactic center have caught glimpses of these flares. Normally, Sagittarius A is faint, glowing so dimly in X-rays that it blends into the cosmic background. Then, without warning, it brightens by factors of 100 or more, releasing bursts of energy that light up detectors on Earth. These flares last only a few hours, vanishing as quickly as they arrive, like sparks in a fireplace, sudden and brief against the quiet dark. And yet, even in their brevity, they are colossal. A single flare from Sagittarius A can release more energy than our sun produces in an entire year. Imagine that for a moment. The steady radiance of the sun, which has burned for over 4 billion years, is outshone in a heartbeat by a black hole that normally appears dormant. The contrast is staggering, a reminder that power need not be constant to be immense. There is an eerie beauty to these eruptions. They reveal the black hole's hidden appetite, its capacity for violence, its ability to transform silence into fury. One might think of it as a sleeping beast that twitches in its dreams, occasionally baring its teeth before returning to slumber. Or perhaps it is more like a thunderstorm breaking across a still plain, lightning tearing the night apart before the calm resumes. Astronomers study these flares with fascination because they are windows into processes we cannot otherwise observe. The matter that falls toward Sagittarius A becomes a laboratory for physics at the edge of possibility. Magnetic fields twist and snap, particles are accelerated to near the speed of light, and radiation floods outward. Each flare is a brief experiment written across the cosmos, a reminder that the quiet giant carries storms within its core. And what causes these sudden awakenings? Often, it is a cloud of gas drifting near the event horizon. These clouds are fragile, easily shredded by the black hole's tidal forces. As they break apart, their fragments spiral inward, colliding, heating, and glowing. At other times, it may be a star that strays too close, stripped of its outer layers, its substance torn away and fed to the darkness. Whatever the source, the pattern is always the same. Silence, then flare, then silence again. To witness such an event, even from a distance, is to feel the raw imbalance between human scale and cosmic scale. A flare might last only a few hours, and yet it dwarfs anything humanity has ever created. It is the difference between a candle and a supernova, between a whisper and a scream. The black hole does not need to shout constantly. A single flare is enough to remind us of its strength. There is a paradox here, one that deepens the sense of mystery. The very same object that spends most of its time invisible, hidden, and subdued is capable of sudden outbursts that rank among the most violent phenomena in the galaxy. It is both absence and eruption, both silence and storm. To live in a galaxy with such a presence is to dwell in a house with a sleeping furnace, quiet for now, but capable of fire at any moment. And yet, strangely, these flares are not only destructive, they serve a purpose, shaping the environment of the galactic center. The energy released by Sagittarius A pushes gas outward, stirs magnetic fields, and influences the birth of new stars. In this way, the black hole does not simply consume, it also gives back, redistributing energy, affecting the structure of the galaxy itself. Each flare is a message, a ripple of influence spreading outward across the Milky Way. Imagine watching from a starship parked at a safe distance, millions of kilometers away. For days you drift in darkness, surrounded by the faint glow of distant stars. Sagittarius A lies before you, invisible except for the whirling motions of stars around it. Then suddenly, without warning, the void brightens. A flare bursts into existence, flooding the sky with X-rays and radio waves. Instruments strain to keep up, overwhelmed by the surge. And just as suddenly, the glow fades, leaving only the silence again. It would feel like witnessing the breath of a god, immense and fleeting, overwhelming and gone. For astronomers, these events are treasures. They capture them with telescopes orbiting Earth, with radio arrays spread across continents, with detectors sensitive to the faintest whispers of energy. Every flare adds to the record, every outburst another clue to the mystery of black holes. Sagittarius A, in its brief moments of hunger, becomes a teacher, a phenomenon we can observe and analyze. And for humanity, these flares hold a deeper meaning. They remind us that power does not always reveal itself openly. Sometimes it waits in silence, biding its time, choosing its moments. The universe is not constant in its expression. It is patient, uneven, unpredictable. Sagittarius A embodies that truth, teaching us humility in the face of forces we cannot control. So when silence breaks, when the quiet giant stirs and flares, it is not just an act of consumption. It is a revelation. It shows us what lies beneath the surface, what potential sleeps within the void. Behind the quietness lies raw, unimaginable power. And when that power is released, it becomes more than the monster of our fears. It becomes a laboratory, a natural stage upon which the deepest laws of physics are played out, waiting for us to watch, to wonder, and to learn. There are places in the universe where ordinary rules begin to bend, places where the familiar framework of reality starts to dissolve into something strange and unfamiliar. The region around Sagittarius A is one of those places. Here, gravity is no longer the gentle pull that keeps us grounded on Earth, or the force that guides planets in their quiet orbits around the sun. Here, gravity becomes an artist, sculpting light, stretching time, twisting space into shapes we can barely imagine. If the universe is a grand experiment, then Sagittarius A is its most exquisite laboratory. For centuries, humans believed gravity was simple. Isaac Newton described it as an invisible tether between objects, a pull that held the moon in orbit and kept apples from floating away. His vision was powerful and elegant, and for hundreds of years it explained the world with astonishing accuracy. But in the early 20th century, Albert Einstein proposed something far more radical. He suggested that gravity was not a force at all, but a bending of space-time itself. Picture a trampoline stretched taut. If you place a heavy ball in the center, the fabric sags, creating a curve. Smaller objects rolled across the surface will spiral inward, not because they are pulled by a mysterious force, but because they are following the curve of the fabric beneath them. This, Einstein said, is how the universe works. Planets orbit stars because the stars bend the fabric of space-time around them. Light bends near massive objects because it too follows the warped geometry. And black holes, those most extreme objects of all, are the deepest wells in this cosmic fabric. Sagittarius A is a perfect stage upon which to test this theory. Nowhere else in the Milky Way does gravity act with such intensity. The stars near the galactic center race in tight orbits, caught in space-time's steepest curve. Light itself is distorted, stretched, and delayed as it passes close by. Even time behaves strangely, slowing down in the presence of such overwhelming gravity. If Einstein was correct, then the evidence should be written in the behavior of these stars. And so astronomers turned their eyes and their patience toward the galactic center. Over decades, they tracked the motion of stars like S2, watching them orbit Sagittarius A in dizzying ellipses. Every flicker of light from these stars carried information, subtle shifts that revealed how gravity shaped their paths. The closer the stars passed to the black hole, the more they betrayed the predictions of relativity. In 2018, scientists confirmed something astonishing. As S2 made its closest pass around Sagittarius A, the light it emitted showed signs of gravitational redshift. In simple words, its light was stretched to longer, redder wavelengths by the immense pull of the black hole. This was not a trick of atmosphere or instrumentation. It was exactly what Einstein's theory predicted. Gravity had bent not only the star's path, but the very light it produced. Imagine the elegance of that. A star, tens of thousands of light years away, whirling around a hidden giant, carries within its flickering glow the fingerprints of space-time itself. To capture such detail required decades of patience, instruments of extraordinary precision, and the combined effort of many generations of astronomers. And yet the result was simple, almost poetic. Einstein was right. Gravity is not a force in the Newtonian sense. It is the bending of the universe's fabric, and near Sagittarius A star, that bending is unmistakable. But relativity is more than an abstract idea. It changes how we think about reality. Time, for example, is not absolute. Near a black hole, clocks run more slowly compared to those in weaker gravitational fields. If you hovered near Sagittarius A for a while, then returned to Earth, you would find that more time had passed here than you experienced. The black hole warps not only space, but the flow of moments, stretching and twisting them like clay. This is where the laboratory becomes philosophical. What does it mean that time itself is not universal? That the ticking of clocks and the aging of lives depend on where you are and how strongly gravity grips you? Sagittarius A demonstrates this with quiet certainty. It is not merely a black hole. It is a classroom in which the very nature of reality is taught. Astronomers continue to probe this classroom, designing experiments that use the stars as test particles, the black hole as the chalkboard, and the universe itself as the teacher. They look for tiny deviations, subtle anomalies, anything that might suggest Einstein's theory is incomplete. Because somewhere, at some scale, relativity must meet quantum mechanics, and in that union lies the key to a deeper understanding of the cosmos. Sagittarius A, by its very existence, invites us to search for that union. And there is wonder in the thought that the center of our galaxy, a place we will never reach, serves as a testing ground for the most profound ideas of physics. We cannot touch it, cannot see it directly, and yet it teaches us about time, space, and the limits of knowledge. The laboratory is vast, the instruments are stars themselves, and the teacher is silence. To grasp this is to glimpse the humility of science. We, tiny beings on a fragile planet, have dared to look into the heart of the galaxy and ask it to reveal the structure of reality. And the galaxy has answered, not in words, but in orbits and light. Every swing of S2, every flicker from a nearby star, every flare from falling gas becomes a data point in a cosmic experiment. The results, so far, affirm Einstein's vision. But there is also a sense of unfinished business. Relativity explains much, but not everything. Quantum physics, which governs the very small, seems at odds with relativity, which governs the very large. Black holes are where these two realms collide, where infinities appear and equations falter. Sagittarius A star is more than a proof of Einstein's brilliance. It is also a puzzle, a reminder that our understanding remains incomplete. So the laboratory continues to beckon. Each new observation brings us closer, and each unanswered question pulls us deeper into the mystery. It is as though the black hole is not merely swallowing matter, but also guarding secrets, holding within its event horizon truths we are not yet ready to see. The universe tempts us with hints, then withdraws, forcing us to stretch our minds in pursuit. There is a quiet beauty in this. A black hole, so often imagined as pure destruction, becomes instead a place of learning. It does not speak, yet it teaches. It does not move, yet it shapes knowledge. It is a paradox, both silence and revelation, both barrier and window. And perhaps that is the greatest lesson of all. For when we look towards Sagittarius A star, we are not just studying a black hole. We are confronting the nature of space, the meaning of time, the fabric of reality itself. And though it feels far away, 26,000 light years beyond our reach, its lessons ripple outward, touching us here, now, in every clock that ticks, in every orbit that turns, in every dream of understanding. But to truly test these ideas, to confirm what theory predicts and perhaps discover what theory cannot, humanity needed more than patience. It needed vision. It needed to see the unseeable, to capture the very shadow of the black hole itself. There are moments in human history when imagination meets reality, when something long thought to be invisible suddenly takes form. For centuries, black holes were only theories, whispers of mathematics on chalkboards, strange consequences of Einstein's equations that even he doubted could truly exist. They were the monsters lurking at the edges of science, unseen yet deeply feared, paradoxes born from the bending of spacetime. And then, in 2022, humanity finally looked into the heart of our own galaxy and saw one. The Event Horizon Telescope, or EHT, was the instrument of this vision. It was not a single telescope, but a network of radio dishes scattered across the Earth, from the frozen plateau of Antarctica to the volcanic peaks of Hawaii, from deserts in Chile to mountains in Spain. By linking them together with exquisite precision, astronomers created a planet-sized eye capable of resolving details as sharp as seeing a donut on the surface of the moon. This was the scale of observation needed to glimpse Sagittarius A star, that hidden anchor at the Milky Way's center. And what they captured was astonishing. Not a traditional picture, crisp and clear like a photograph, but an image made from waves of light stitched together across continents. It showed a ring of orange fire, uneven and flickering, circling an abyss of darkness. The darkness itself was not the black hole, but its shadow, the region where light is bent so severely that it cannot escape. Around that shadow swirled hot plasma, glowing with the energy of matter spiraling inward before its final fall. It was more than an image. It was proof. Theories had predicted what such a shadow should look like, and here it was. Real, shimmering on the screens of astronomers who had dedicated years of their lives to catching a glimpse of the unseeable. To gaze at it was to look at the edge of time itself, the boundary beyond which nothing returns. But capturing Sagittarius A was far more difficult than its distant cousin, M87, which had been imaged by the same telescope network in 2019. M87 is a monster, billions of times the mass of the Sun. And though it is far away, its immense size makes its shadow relatively stable. Sagittarius A star, on the other hand, is small by cosmic standards, only 4 million solar masses. That may sound immense, but in the realm of supermassive black holes, it is modest. Its smaller size means the matter swirling around it orbits in mere minutes, constantly shifting and flickering. Imagine trying to take a long exposure photograph of a candle flame tossed about by the wind. That was the challenge faced by the scientists of the EHT. Sagittarius A was not a still object, but a restless one, changing faster than the telescope could collect its data. The final image was not a snapshot frozen in time, but a portrait assembled from many shifting moments, like capturing a heartbeat in motion. What emerged was not a single frame, but a story of movement, stitched together by patience, mathematics, and imagination. And yet, there it was, unmistakable. A dark center, surrounded by a glowing halo, exactly as Einstein's theory had foretold. The shadow was about 50 micro-arcseconds across, so small that it was like looking at a tennis ball on the moon. And within that tiny circle lay the culmination of decades of work, the collaboration of hundreds of scientists, and the confirmation of one of the universe's strangest predictions. The impact was immediate and profound. For astronomers, it was a triumph of technique and theory, a demonstration that the cosmos could be read like a book, even when its letters are made of invisible light. For ordinary people, it was something more visceral, more emotional. To look at that glowing ring was to face the unimaginable, to see with human eyes what had once existed only in thought. It was not a simulation, not an artist's impression, but reality itself. There is a quiet awe in knowing that the center of our galaxy, invisible for so long, has been revealed to us in this way. The image is not sharp like the photographs we take of planets or nebula, but its blur is part of its truth. It reflects the turbulence of the plasma, the restless dance of matter at the edge of destruction. In its imperfection, it becomes more alive. Sagittarius A is not a still portrait. It is a living flame, a cosmic heartbeat pulsing at the center of the Milky Way. And there is something deeply human in this pursuit. To connect telescopes across the Earth, to synchronize them to the precision of atomic clocks, to gather petabytes of data and ship them across oceans, all so that we might see a shadow 26,000 light years away. This is an act of faith as much as science. Faith that the universe is knowable, that patience yields truth, that what we imagine can one day be seen. The shadow itself carries meaning beyond science. It is a symbol of boundaries, the ultimate horizon. We cannot see inside it, cannot know what happens beyond the veil. And yet its very outline tells us that the universe is both open to inquiry and forever mysterious. It invites us closer, even as it pushes us away. Looking at that shadow is like standing at the edge of a cliff, gazing into an abyss that is both terrifying and beautiful. And in another sense, the shadow is a mirror. It reflects back to us our own smallness, the brevity of our lives compared to the vast stretches of cosmic time. It asks us to consider what it means to exist in a galaxy where such forces are at play, silent and indifferent, yet shaping everything we know. The shadow does not care that we have seen it. It does not change because of our gaze. And yet, for us, the act of seeing transforms everything. Perhaps that is why the image of Sagittarius A feels so profound. It is not simply a scientific result. It is an encounter with mystery, captured in the language of light. It shows us that there are places where knowledge ends, where certainty fades into darkness. And yet it also shows that even there, on the very edge of the unknowable, we can still learn, still glimpse, still wonder. The first time the image was released, it spread across the world in moments, appearing on screens in classrooms, in living rooms, in news reports. Children stared at it with wide eyes, while adults whispered about the beauty of something so far beyond them. For a moment, humanity was united by a picture not of ourselves, but of the abyss that holds us all. And so the Event Horizon Telescope gave us more than data. It gave us perspective. It reminded us that we are part of something immense, that our galaxy has a heart, and that this heart is both darkness and fire. The shadow is not merely a scientific achievement. It is a human story of curiosity, of perseverance, of wonder. But images alone do not answer every question. They open new ones. What does this shadow truly mean for us? Is it only a symbol of destruction, or could it also be a key to understanding creation? Does it show us the limits of knowledge or the beginning of something deeper? When the image of Sagittarius A was first revealed, many assumed they were looking directly at the black hole itself. But that is not quite true. What we see in that glowing ring and dark center is not the black hole, but its shadow. The black hole itself is invisible, hidden beyond a boundary from which no light can ever escape. What the Event Horizon Telescope captured was the outline of the unseeable, the edge of a cosmic abyss. This edge is called the event horizon. It is not a solid surface, not a wall or a shell, but a limit written into the fabric of space-time. To cross it is to leave the universe we know. Beyond it, all paths bend inward, all directions lead only to the center, and no signal, no light, no whisper of information can return. It is the ultimate one-way door, a horizon that is not made of matter, but of geometry. Imagine standing on the shore of an ocean, gazing at the horizon. Beyond that line, the world continues, but from where you stand, it is forever hidden. The event horizon is like that, but far more absolute. On Earth, if you move or climb, the horizon changes. At a black hole, no change of position, no leap of imagination can pierce the veil. The horizon is fixed, a boundary not of vision, but of possibility itself. The shadow we see in images of Sagittarius A is slightly larger than the horizon itself. It is created by light that passes close to the black hole, bent by gravity into circular orbits before escaping. These photon paths form a bright, glowing ring, while the center remains dark. What we call the shadow is really the absence of light from within, surrounded by the last desperate cries of lies of light that narrowly escaped. There is something haunting in that thought. The darkness we see is not a physical thing, but the shape of lost possibilities. It is the silence of all the light that could not reach us. It is a void drawn not by presence, but by absence. In that sense, the black hole's shadow is not only an astronomical object, but also a metaphor. It is a reminder of limits, of the places where knowledge itself comes to an end. For centuries, humanity has been pushing against boundaries, asking what lies beyond the next hill, the next ocean, the next frontier. Each horizon we have reached, we have crossed. The event horizon, however, is different. It is not a frontier that can be overcome with ships or rockets or telescopes. It is the point where the very rules of physics prevent us from looking further. Beyond it lies mystery, perhaps chaos, perhaps order. But whatever truth exists, there is hidden from us by the most absolute curtain imaginable. And yet, that very boundary is what makes black holes so fascinating. They are paradoxes, both knowable and unknowable, objects we can study with exquisite detail and yet never fully comprehend. The shadow of Sagittarius A is both a triumph and a taunt. It says, "Here is the shape of the invisible," but it also whispers, "You shall see no further." This tension has profound implications. Scientifically, it challenges us to rethink the limits of observation. Philosophically, it forces us to confront the idea that reality itself may contain secrets that cannot be unveiled. Culturally, it resonates with our deepest myths of forbidden places, of underworlds and hidden realms, of doors that can be entered but never exited. Every civilization has imagined such boundaries. In Sagittarius A star, we see one written into the cosmos itself. There is a certain humility in gazing at this shadow. We are reminded that not everything is ours to claim, that the universe is not an open book, but a library with locked rooms. Knowledge has edges, and the black hole marks one of them. To know this is not to despair, but to feel wonder at the fact that such limits exist at all, and that we, fragile creatures on a small planet, can perceive them from afar. Consider what it means that the shadow of Sagittarius A star is visible to us at all. It is 26,000 light-years away, hidden behind clouds of dust and gas. Yet, by combining the power of telescopes across the Earth, we have drawn its outline. The darkness we see today is the same darkness that existed when early humans painted on cave walls, when civilizations first raised their eyes to the stars. For all those thousands of years, the shadow has been there, shaping the galaxy, unseen. And now, for the first time, we have caught a glimpse. This glimpse is more than science. It is a meditation on perception itself. We are used to thinking of vision as clarity, as seeing something directly. But here, our most profound vision comes from what is missing. The black hole's shadow is a picture of absence, an image drawn in negative space. It teaches us that sometimes to see the most important truths, we must look not at what is there, but at what is not. And yet, though the black hole itself remains hidden, its influence does not. The event horizon may seal its secrets forever, but the effects ripple outward, shaping stars, bending light, stirring gas clouds across vast distances. The shadow is only the innermost boundary of a sphere of influence that extends across the entire galaxy. The darkness may hold silence, but its presence resonates everywhere. Perhaps that is the most profound lesson of all. A black hole is not defined only by what it takes in, but by the shape it gives to the world around it. The shadow marks the edge of loss, but also the beginning of connection. It is a boundary that cannot be crossed, yet from its existence flows a galaxy's story. When we look at the shadow of Sagittarius A star, we are not only gazing into darkness, we are seeing the imprint of something vast and invisible on everything else. It is the fingerprint of gravity, the architecture of spacetime, the scar left by a collapse so complete that it rewrote the laws of nature. And through it, we are reminded that even when something hides itself from view, it can still shape the universe profoundly. In that sense, the black hole's shadow is not a void at all. It is presence, distilled into its most enigmatic form. It is the shape of influence, the outline of power, the boundary between the known and the unknowable. It tells us where science must stop, but also where imagination must begin. And so, the shadow of Sagittarius A is not only an astronomical phenomenon, it is a mirror of our own longing to know and our acceptance that some mysteries remain. It is the reminder that even in the age of telescopes that span the Earth, there are still places we cannot reach. Yet paradoxically, that limit draws us closer. We cannot see beyond the horizon, but we can feel its gravity, see its effects, and weave its story into our own. The event horizon is silence, but the galaxy around it speaks. And that voice, that influence, extends far beyond the boundary of darkness. It flows outward into the Milky Way, into the stars we see each night, into the structure of the very galaxy we call home. When people imagine a black hole, they often picture it as a hungry monster, devouring anything that strays too close. Sagittarius A is certainly capable of that, but to think of it only as a destroyer is to miss its deeper role. It is not just a prisoner of gravity, silently lurking at the center of the Milky Way. It is also the galaxy's sculptor, the hidden architect that helps shape the stars, the gas, and the very spiral we see when we look upon our home from afar. Every galaxy has a heart, and in nearly all cases, that heart is a supermassive black hole. The Milky Way is no exception. Sagittarius A, though quiet compared to its cousins in more active galaxies, exerts an influence that stretches across tens of thousands of light-years. Its presence provides the gravitational anchor around which the entire galaxy revolves, a kind of invisible core that holds everything together. Without it, the Milky Way might be looser, less stable, perhaps even unrecognizable. Consider the stars. The orbits of those nearest to Sagittarius A star are like dancers around an unseen stage partner. Their paths are determined not just by the mass of their neighbors, but by the central weight of the black hole itself. On grander scales, the galaxy's spiral arms, those majestic arcs that sweep across space, owe their cohesion in part to this anchor at the core. Sagittarius A is silent, but it is also steadfast, providing the gravitational balance that keeps billions of stars bound together. Its role extends beyond mere anchoring. The black hole's outbursts, rare though they are, send shock waves of energy rippling through the galactic center. These flares can heat gas clouds, preventing them from collapsing into stars, or they can stir them into turbulence that ultimately triggers star formation in unexpected places. In this way, Sagittarius A regulates the life cycle of stars, sometimes delaying their birth, other times accelerating it. Like a gardener who prunes a tree, it shapes the galaxy not by constant attention, but through decisive, powerful moments. Astronomers suspect that the Milky Way's history has been deeply influenced by these interactions. Long ago, Sagittarius A star may have been more active, devouring gas and stars at a furious pace, releasing jets and winds that pushed matter outward. Evidence of this still lingers in the form of the Fermi bubbles, two colossal lobes of high-energy radiation that balloon above and below the galactic plane. These vast structures, stretching tens of thousands of light years, are relics of an ancient feeding frenzy, when the black hole's appetite briefly transformed the Milky Way's appearance. The memory of that activity is written in the distribution of stars and gas even today. The central bulge of the Milky Way, a crowded sphere of old stars surrounding Sagittarius A, may have been shaped by the black hole's energy output long ago. The star-forming regions nearby, with their clusters of massive young suns, are influenced by how gas flows are directed or suppressed by the black hole's gravitational pull. In this sense, Sagittarius A is both artist and editor, adding and subtracting material, refining the structure of the galaxy with each decision of physics. What makes this role so fascinating is its balance of violence and order. A black hole's flares and winds can appear destructive, stripping away matter, halting star formation in certain regions. But in the longer view, this regulation prevents chaos, ensuring that stars do not form too quickly or in the wrong places. It maintains a rhythm, a galactic heartbeat that keeps the Milky Way from burning through its fuel too fast. Without such regulation, the galaxy might have flared brightly for a brief time, only to exhaust itself prematurely. Instead, it has been guided into a more measured, sustainable pattern, one that has allowed Earth and life itself the time to emerge. This realization is humbling. The stability of our galaxy, and by extension the conditions that allowed humanity to arise, may owe much to the silent influence of Sagittarius A. If the black hole had been more violent, the Milky Way could have been stripped of the gas needed for star formation. If it had been too passive, star formation might have run rampant, consuming material in a blaze of youthful chaos. Instead, it seems to have walked a delicate line, fierce at times, calm at others, creating a balance that persists across billions of years. Think of it as an architect who designs not with bricks or stone, but with gravity and time. The walls of this galactic cathedral are made of stars, its corridors of gas and dust, its stained glass windows of nebulae and glowing clusters. At the center of it all lies an architect who never shows their face, who leaves behind no plans, only the silent evidence of design written into the galaxy's very structure. We live within that cathedral, often unaware of the architecture surrounding us, until we pause to look up at the night sky and wonder. There is also a sense of reciprocity here. While Sagittarius A star shapes the galaxy also feeds and sustains it. Streams of gas drift inward over millennia, providing the raw material that occasionally awakens the black hole from its slumber. Stars wander too close and are torn apart, their matter fueling brief outbursts of activity. In this way, the Milky Way and its black hole are locked in an eternal dance, each influencing the other's destiny. Neither could exist in the same form without the other. Without Sagittarius A star, the Milky Way might not exist as we know it. Its spiral arms might never have formed so elegantly, its bulge of stars might not have grown so densely, and its ability to sustain billions of suns for billions of years might have faltered. We are, in some deep sense, children of the black hole, products of its unseen influence. Even here on Earth, far from the galactic center, The balance it provides has shaped the conditions of our lives. To recognize this is to reframe the black hole's identity. It is not merely a cosmic devourer, not merely a dark pit of destruction. It is also a caretaker, a regulator, a silent designer that ensures the galaxy's story continues. In its stillness, it holds together a vast system of stars. In its occasional fury, it reshapes the distribution of matter, creating the conditions for future generations of suns and planets. But architects, even silent ones, are not always gentle. Sagittarius A may be balanced, but it is not safe. The same forces that sculpted the Milky Way could one day threaten its inhabitants. Its gravity, its flares, its influence, all of these carry risks for the stars and planets that orbit within its reach. The architect that shaped our home may also hold dangers yet to be revealed. Black holes live in contradiction. They are creators and destroyers, givers and takers, silent watchers and sudden storms. Sagittarius A embodies this paradox perfectly. For most of its life, it has slept, its immense gravity pulling but not feasting, its influence constant but subtle. Yet beneath that calm exterior lies a possibility, a tension, the sense that at any moment the quiet could end and the giant could stir. Imagine a storm far out at sea. From the shore, it looks calm, distant, even harmless. But sailors know that storms are not defined by how they appear in the moment. They are defined by potential, by the suddenness with which calm waters can turn to chaos. Sagittarius AC is much the same. Right now, it is quiet. For centuries, perhaps millennia, it may remain this way. But if a massive star drifts too close, or if a great cloud of gas falls inward, the storm will awaken. What would that mean for our galaxy? The black hole's hunger, when stirred, does not satisfy itself gently. Matter pulled too close would be torn apart by tidal forces, stretched and shredded into streams of plasma. That plasma would spiral inward, heating as it falls, until it glows brighter than millions of suns combined. The eruption of energy would not be contained. X-rays and gamma rays would burst outward, heating surrounding gas, driving shockwaves across light years of space. Astronomers suspect this has already happened. The Fermi bubbles, those twin lobes of radiation towering above and below the Milky Way's plane, are relics of a time when Sagittarius A fed more aggressively. Those structures extend tens of thousands of light years, silent proof that the black hole once released power on a scale that reshaped entire regions of the galaxy. If it happened before, it could happen again. For Earth, 26,000 light years away, such an eruption would not spell instant doom. The distance is a buffer, a protective cushion of emptiness that dilutes even the fiercest cosmic violence. But distance does not erase possibility. If Sagittarius A were to consume a large enough meal, the resulting outburst could alter the Milky Way's rhythm. Star formation could be suppressed in the galactic center. Gas could be blown away from the regions where new suns are born. Over immense timescales, the balance of our galaxy could shift. In one sense, this threat is abstract. The human lifespan is a blink compared to galactic cycles, and the odds of witnessing such a flare in our brief window of time are slim. Yet the knowledge of it lingers in the imagination like the scent of rain carried on the wind before a storm. It reminds us that our galaxy is alive, dynamic, restless, and that we are not immune to its moods. There is also a subtler threat, one less immediate but no less unsettling. Black holes are unpredictable. Their very nature challenges our ability to foresee their actions. Astronomers can measure orbits, track stars, estimate the flow of gas, but the moment when a black hole awakens is not something we can schedule in a calendar. It is a possibility always present, like a quiet whisper at the edge of thought. That whisper is what makes Sagittarius A so haunting. It is not a danger we can prepare for in the way we prepare for earthquakes or hurricanes. It is not an enemy to fight or a puzzle to solve. It is a presence, a reminder that the universe does not conform to our sense of stability. The galaxy's sculptor is also its sleeper, and when it dreams of hunger, the entire Milky Way can change. Some might find this terrifying, but there is another way to see it. The threat is not only destructive, it is also creative. Outbursts from black holes can trigger star formation in distant regions, compressing clouds of gas until they ignite. They can shape galaxies into new forms, sculpting beauty out of chaos. Even destruction on cosmic scales carries within it the seeds of renewal. In this way, Sagittarius A mirrors life itself. Endings and beginnings are entwined, loss and creation feeding one another in cycles too vast for us to fully grasp. Still, the possibility of violence stirs reflection. What does it mean to live in a galaxy where the central heart can awaken with such ferocity? For some, it is a reminder of fragility, a truth that life is precious precisely because it is not guaranteed. For others, it is a source of awe, a recognition that we belong to a universe that is neither safe nor tame, but endlessly alive. Perhaps it is both. Take a moment to imagine standing under a night sky untouched by city lights. Every star you see owes its place, in some indirect way, to the silent weight of Sagittarius A. Now imagine that at the center of it all is a storm waiting to happen, a sleeper that might one day breathe fire into the galaxy again. Does that thought make the stars feel closer or more distant? Does it make you feel small, or does it connect you to something larger than fear, something that spans the entire cosmic web? There is no single answer. The sleeping threat of Sagittarius A is both humbling and inspiring. It teaches us that even in apparent stillness, forces beyond our comprehension are at work. It teaches us that calm is not permanent, that silence often hides power, that the universe is written not in certainties, but in potentials. And so we live our lives under the shadow of a possibility. It is not an urgent one, not the kind that keeps astronomers awake at night in worry, but it is real. The galaxy is shaped not only by what happens, but by what could happen. The presence of Sagittarius A is as much about its potential as about its history. Like a storm on the horizon that may never arrive, it colors the way we see the sky, reminding us that we are part of a story whose next chapter may be written in fire. But as much as this black hole carries threat, it also carries meaning. Beyond fear, beyond speculation, lies a deeper question. What does it mean for us, as beings conscious of our place in the cosmos, to know that our galaxy is bound to such a force? What do we learn, not about black holes, but about ourselves, when we contemplate the presence of Sagittarius A star? There is a peculiar stillness that comes when one pauses to think of it. Beneath the everyday noise of life, the hum of machines, the rush of voices, the pulse of human worries, there is the quiet knowledge that 26,000 light-years away, at the heart of the Milky Way, lies a black hole. Not just any black hole, but Sagittarius A, a mass 4 million times greater than our Sun, heavy enough to bend the orbits of stars, silent enough that most of us live entire lives without giving it a thought. To realize this is to be struck by humility, the kind that presses gently but firmly against the imagination. For most of history, humanity has looked upward and told stories. The constellations were once gods and hunters, queens and monsters. The stars were fixed points in a grand celestial sphere, perfect and unchanging. Now we know differently. Every star we see is not simply decoration, but part of a vast system, moving in paths dictated by gravity. Every orbit of every star near the galactic center is a step in a cosmic dance, choreographed by the black hole. And we, here on Earth, are part of that same dance. Our Sun, too, is in orbit around Sagittarius A, circling once every 220 million years. Without that gravity at the core, our galaxy would fly apart, its spiral arms unraveling like threads pulled from a tapestry. It is strange to think that our world, with all its struggles and triumphs, its histories and dreams, is itself just a speck caught in that motion. We are passengers on a planet, circling a star, circling a black hole, all within a galaxy that drifts through the universe. The scale stretches far beyond what words can hold. And yet, what is most remarkable is not our smallness, but our awareness of it. No other creature we know of has stood on Earth, looked into the sky, and realized that they are bound by the pull of an invisible abyss thousands of light years away. No other life form has built telescopes to track the invisible or written equations that predict the orbits of stars around a void. This ability to see beyond immediate survival, to understand something so utterly abstract, is profoundly human. We are not just witnesses to Sagittarius A. We are interpreters. We take the silent evidence of stars curving through space and weave it into knowledge, into meaning, into a story of where we come from. There is a paradox in this. The black hole reminds us of our smallness, of the fragility of life against the vastness of the cosmos. And yet, in knowing that, we experience something immense. The very act of perceiving the abyss transforms it from a cold fact into a reflection of ourselves. Our minds, shaped by evolution on a tiny planet, can reach out and grasp the existence of a force that bends space and time itself. That awareness, fragile though it may be, is a light in the darkness. When one considers Sagittarius A star, humility deepens into awe. We are not at the center of the universe, nor are we masters of it. We are part of a structure so much larger than ourselves, and yet we are capable of understanding that structure. The galaxy does not notice us, but we notice it. The black hole does not care, but we care. To some, this may feel like insignificance. To others, it feels like belonging, as though by knowing the abyss we claim our place within it. Take a moment to imagine it. Every day of your life has been spent orbiting not just the sun, but Sagittarius A star. Every memory you have ever held, every moment in human history, every rise and fall of civilizations has occurred while our entire solar system drifted slowly along its vast elliptical path around the galactic center. You were born into this orbit without choice, yet now, knowing it, you can almost feel the motion. The Earth spins, the sun circles, the galaxy turns. You are not separate from it. You are part of it, woven into the same rhythm that binds stars and black holes together. And there is something else. To recognize the abyss at the heart of our galaxy is also to recognize resilience. Black holes are often described as destroyers, but our existence shows that they can also be sustainers. For billions of years, Sagittarius A star has held the Milky Way together, and in that time, life emerged on a tiny world far from the galactic center. That balance, fragile though it may be, was enough for us to rise, to question, to wonder. Against the pull of the abyss, life insisted on blooming. Perhaps that is why thinking of Sagittarius A feels so human. It mirrors something within us, the coexistence of fragility and strength, of silence and expression, of smallness and vastness. We carry within our minds both the fear of falling into darkness and the courage to look into it and ask what it means. There is, of course, a sobering lesson as well. To contemplate a black hole is to confront limits. No matter how much we learn, we cannot see beyond the event horizon. There will always be mysteries hidden inside, truths that remain beyond reach. For some, this boundary is frustrating, a reminder that our knowledge has edges. But there is beauty in it too. The abyss reminds us that the universe is larger than our comprehension, that there will always be more to seek, more to imagine. Perhaps meaning is not found in answering every question, but in dwelling in the space where questions remain open. So, to stand on Earth and know there is a black hole at the center of our galaxy is to hold two truths at once. We are small and we are aware. That awareness gives weight to our existence, making every glance at the night sky more profound, every star a reminder of the silent force holding the galaxy together. We belong not to an isolated world, but to a grand orbit, a shared journey with billions of suns and worlds. And yet there is more. For black holes are not just about space, they are about time. Sagittarius A is not only an anchor of gravity, but also a gateway into deeper mysteries. It whispers something about how time itself behaves, bending and stretching in ways our daily lives never reveal. The abyss is not merely an object, it is a question carved into the fabric of the universe. Time is something we rarely question. It seems steady, dependable, moving forward at a constant pace from moment to moment. We live by its rhythm. We measure our days in hours, our lives in years. Yet near a black hole like Sagittarius A, time refuses to obey these simple expectations. It bends, it stretches, it slows. What feels steady here on Earth becomes strange and uncertain there. To approach Sagittarius A is not just to enter a different region of space, but to enter a different experience of time itself. Imagine carrying a clock into the orbit around the black hole. As you glance at its face, the seconds tick as usual. To you, nothing feels different. Your heartbeat is steady, your thoughts flow as they always have. But from far away, to someone watching from Earth, your clock would appear to slow. The closer you drift toward the event horizon, the more the seconds would stretch, until near the boundary they would almost freeze. To the outside universe, you would seem caught in a kind of pause, suspended at the edge of eternity. This is not illusion, but the consequence of Einstein's general theory of relativity. Mass and energy bend space-time, and near a black hole, that bending becomes extreme. Space curves inward, and with it, time itself becomes distorted. A black hole is not only a place where matter disappears, but a region where the very fabric of reality is reshaped. Sagittarius A is not just 4 million suns crushed into darkness. It is also a kind of engine of time, warping the flow of moments in ways that defy intuition. To think of this is unsettling. We like to imagine time as universal, the same everywhere. But relativity teaches otherwise. Time is local, personal. Your seconds are not the same as mine if we move differently through space, and they are certainly not the same near a black hole as they are here on Earth. That means reality itself is layered, with different rhythms unfolding in different places, all existing simultaneously. It is as if the universe plays multiple melodies at once, each one true in its own key. For astronomers, this bending of time is not just philosophy. It is something that can be measured. The stars near Sagittarius A star move so quickly and so close to its immense gravity that their orbits allow us to test relativity with extraordinary precision. As they swing by the black hole, the light from these stars is stretched, redshifted, by the warping of space-time. By observing them, scientists confirm what Einstein predicted more than a century ago, that gravity is not simply a force pulling objects, but a sculptor of time itself. But beyond the equations lies the human impact of such knowledge. To imagine standing near Sagittarius A, watching the universe around you race ahead while your own clock slows, is to feel the ground of reality shift beneath your feet. Time, which seems so constant in daily life, is revealed as fragile, pliable, dependent on context. The abyss is not only a hole in space, it is a hole in our assumptions about reality. Take a moment to dwell on this. If you were to hover safely near the black hole while centuries passed on Earth, what would that mean? Could you return to find your world unrecognizable, your loved ones gone, history rewritten while you had lived only hours? In science fiction, this becomes a story of time travel, of journeys into the future. But even stripped of fantasy, the fact remains. Black holes are places where the flow of time itself can be altered. They are not just locations. They are experiences, and those experiences are alien to what we know here. This realization brings a strange kind of intimacy with the universe. Time is not something imposed upon us from outside. It is something we share with the cosmos, shaped by gravity, motion, and distance. To know that our seconds are tied to the pull of matter and energy is to feel connected to the stars and black holes, as though even our heartbeat is written into the same fabric that curves around Sagittarius A. It also sparks deeper reflection. If time can bend, what does that mean for our sense of past and future? If clocks can disagree, if moments can stretch or shrink depending on where they are measured, then what is time really? Perhaps it is not a river flowing steadily forward, as we often imagine, but a landscape, a terrain shaped by mass and energy, where different paths unfold at different speeds. In such a view, Sagittarius A becomes not just a destination in space, but a landmark in the geography of time. For philosophers and poets, this is fertile ground. To contemplate a black hole is to contemplate limits, not only the limit of what can be seen beyond the event horizon, but also the limits of how we understand time itself. The abyss does not just devour matter, it devours certainty. And in the quiet of that uncertainty, we are reminded of how little we truly know. How much mystery still surrounds the universe we call home. Yet there is comfort too. The bending of time near Sagittarius A tells us that the cosmos is richer than we imagine. It is not flat, not simple, not bound to our everyday intuitions. It is alive with possibility, with structures and rhythms beyond human scale. In recognizing that, we are not diminished, we are expanded. We are invited to think beyond ourselves, to stretch our minds as space-time itself is stretched. So the next time you glance at a clock, remember that its steady ticking is only one version of reality. Elsewhere, in the depths of our galaxy, time flows differently, twisted by the presence of an invisible giant. Sagittarius A reminds us that the universe is not a single song, but a symphony, with melodies that slow and quicken, that layer and diverge, that echo across scales of space and time. And this symphony raises a question that draws us deeper still. If black holes distort time, what happens to them across time? They are not eternal, at least not in the way we once thought. Slowly, imperceptibly, they change, they fade, they evaporate through processes we barely understand. The same abyss that bends time is itself caught in time's grip. To know this is to open yet another mystery, one that reaches toward the ultimate fate of black holes themselves. Black holes seem eternal. They appear as unchanging monuments to gravity, dark wells that swallow everything and reveal nothing. When we first learned of them, they were imagined as the ultimate full stops in the story of the universe, endpoints beyond which there could be nothing else. And yet, the deeper we looked, the more fragile that certainty became. Even black holes, it seems, may not last forever. In the 1970s, Stephen Hawking suggested something astonishing. While classical physics painted black holes as absolute prisons, quantum physics whispered a different tale. The boundary of a black hole, the event horizon, is not completely silent. The strange rules of quantum mechanics allow for tiny fluctuations in energy, particles popping in and out of existence in the vacuum of space. Near the event horizon, these fluctuations are altered by the black hole's gravity. One particle may fall in while its partner escapes. To an outside observer, it appears as though the black hole itself is leaking radiation. This faint glow, invisible to our eyes but real in theory, is what we now call Hawking radiation. The implications are staggering. If black holes emit radiation, they also lose energy. And since energy is tied to mass, this means they shrink. Very, very slowly, they evaporate. For a small black hole, the process might be fast on cosmic timescales. For a supermassive one like Sagittarius A, it would take an almost inconceivable span of time. We are speaking not of billions of years, nor trillions, but numbers so large they strain imagination, 10 to the power of 87 years or more. By then, galaxies will have dispersed, stars will have died, and even atoms may have fallen apart. The universe will be cold and dark, and yet, in that darkness, Sagittarius A will still be glowing faintly, releasing its last whispers of energy into the void. To think of this is to be pulled into a perspective so vast it is almost impossible to hold. The black hole that now governs the Milky Way's heart, shaping stars and regulating gas, may one day fade into nothing. The giant will die, not with a roar, but with a sigh, a quiet evaporation into the empty future of the cosmos. The very thing we call eternal is revealed to be temporary, just stretched across a timeline so immense it dwarfs every human measure. And yet, there is beauty in this fragility. If even black holes can die, then the universe is not a place of permanent prisons, but of transformation. Nothing lasts forever, but everything plays a role in the great unfolding. Sagittarius A, for all its mass and gravity, is not exempt from the same truth that guides us all. To exist is to change, to begin is to end, to be part of a cycle larger than ourselves. This realization can stir both melancholy and wonder. On one hand, there is sadness in the thought that even the most powerful objects in the universe will not endure. Our galaxy's sculptor, the silent anchor of our spiral, will one day dissolve into nothingness. On the other hand, there is liberation in knowing that permanence is an illusion. Life is precious precisely because it is fleeting. Stars burn brightly because their fuel is limited. Black holes hold sway because their time, too, will run out. Ephemerality is not weakness, but the very essence of existence. For humanity, the timescales involved ensure that Sagittarius A's evaporation is not something we will ever witness. By the time its glow fades, Earth will long since have ceased to exist, the sun will have gone cold, and whatever descendants of our species remain will have scattered into forms we cannot even imagine. The fate of the black hole is not a story for us, but for the universe itself. It is the last chapter in a book we will never read, but whose outline we can already sense. And perhaps that is enough. To know that black holes evaporate is to glimpse the impermanence woven into every corner of reality. It shows us that the cosmos is not static, not frozen, but alive with change, even in places we once thought immune. It reminds us that time, however vast, always moves forward, reshaping even the darkest and most massive structures. Sagittarius A time may seem unchanging to us now, but it too is caught in the river of becoming. Take a moment to imagine the far future. Picture a universe so ancient that stars no longer shine. Galaxies are ghosts, scattered remnants drifting through darkness. And in the midst of this silence, Sagittarius A remains, glowing faintly, a last ember in the night. Over ages beyond counting, that ember fades until nothing is left but space, empty and quiet. Even then, the memory of its presence lingers. In the stars it once shaped, in the galaxies it once anchored, in the life it indirectly helped to nurture on a small blue world. There is a kind of poetry in that. The giant may evaporate, but its influence will not vanish. The Milky Way itself, as we know it, would never have existed without Sagittarius A star. Its eventual death is part of a longer story, one in which creation and destruction are inseparable. Just as its birth gave structure to a galaxy, its end will return its energy to the universe, contributing to whatever comes after. Perhaps this is the deepest lesson of Hawking's insight. Black holes are not the exceptions to the universe's rules. They are not loopholes where physics stops. They are participants in the same grand cycle that governs stars, planets, and people. They are born, they live, they change, they die. Their lives may be stretched across unimaginable spans of time, but they are lives nonetheless, part of the same cosmic mortality we all share. And so, when we look at Sagittarius A star, we see not only the present, but also the future. We see a black hole shaping our galaxy, and we see a giant destined to vanish. We see permanence and impermanence entwined, eternity revealed as only a longer form of change. We are reminded that even the universe's greatest powers are subject to the same law. Nothing lasts forever, not even the abyss. But until that distant day, Sagittarius A star remains here, at the heart of our galaxy, sculpting, anchoring, guiding. It continues to shape stars, to regulate gas, to remind us of our place within the Milky Way. Its eventual evaporation is a truth for the farthest future, but its presence is a truth for now. The black hole is still awake, still breathing quietly at the center of our cosmic home. When we think of Sagittarius A, the mind drifts first to darkness, a void that cannot be seen, a silence that cannot be touched. Yet around this silence, the most extraordinary testimony is written in light. The stars that orbit closest to the galactic center do not simply live their lives in isolation. They carry within their paths the story of the invisible giant that binds them. They are like dancers circling a hidden partner, their every step revealing what otherwise could not be seen. It was through these stars the existence of Sagittarius A star became more than speculation. Astronomers could not peer directly into the black hole's depths, but they could watch its neighbors. Over decades, careful observations revealed stars that traced impossibly tight orbits around a point of darkness. The most famous among them, a star named S2, moves in a long ellipse that brings it so close to the black hole that it whips around at thousands of kilometers per second. From Earth, 26,000 light-years away, telescopes recorded this dance, year after year, building a picture as precise as any scientific experiment in history. The beauty of this is not just in the measurement, but in the intimacy of it. To follow S2's orbit is to witness gravity at work in its purest form. Each bend of its path, each acceleration as it nears the black hole, is a direct fingerprint of the invisible. It is as though the cosmos itself is playing a melody, and the stars are the notes, resonating with the pull of Sagittarius A star. These orbits have become a kind of cosmic laboratory. General relativity, Einstein's great theory of gravity, makes bold predictions about how mass curves space and time. Near a supermassive black hole, those predictions can be tested with exquisite precision. As S2 swings close to Sagittarius A star, the starlight passing to us stretches and shifts, redshifted by the warping of time itself. This effect, once only a mathematical dream, has now been measured. The universe has confirmed again that Einstein was right. Time near the abyss flows differently than time here. It is difficult to overstate what this means. For most of history, humanity could only wonder about the unseen. Now, with instruments sensitive enough to trace the motion of distant stars, we can reach into the heart of the galaxy and touch the very limits of physics. Every orbit measured is not just astronomy. It is philosophy, proof that human beings can extend their understanding into realms that once seemed unreachable. And there is something deeply poetic in the way these stars bear witness. They are not loud messengers, not violent explosions or dramatic bursts. They are steady, patient travelers, circling endlessly around a darkness that dwarfs them. Each orbit takes years, decades, sometimes centuries, and yet we wait, watching, listening, decoding. Their lives become the text in which the black hole's story is written. If Sagittarius A star is the sculptor of the Milky Way, then these stars are the chisel marks, subtle but undeniable. Take a moment to imagine it. A star, luminous and proud, moving at speeds that defy intuition, tracing a vast ellipse through space. With each pass, it dives near the abyss, its light stretched thin by warped time, then flings outward again into the wider galaxy. It is like a comet around the sun, but magnified to galactic scales. And all the while, we, tiny observers on a pale blue dot, are able to record and predict its motion with such accuracy that even the smallest deviation might hint at new physics. Some astronomers describe this as listening to the heartbeat of the galaxy. Each orbit is a rhythm, a pulse in the darkness. Together, these rhythms weave a song of gravity, subtle and complex, echoing from the galactic core. For us, it is both a scientific triumph and a source of wonder. To know that far away, stars are tracing the edges of invisible curves, and to realize that we can not only detect but understand those curves is to feel both small and infinite at once. The implications stretch further still. By measuring these orbits, we can test whether gravity behaves the same in the extreme as it does here on Earth. So far, Einstein's theory has held firm, but astronomers continue to search for cracks, small hints that another, deeper law lies beneath. Each orbit becomes a question whispered into the void. Is relativity complete, or is there more, something yet unseen, waiting beyond the horizon of our theories? In this way, the stars around Sagittarius A star are more than ornaments of the galaxy. They are our messengers, bridging the gap between human thought and cosmic truth. Their echoes remind us that the universe is not silent, but always speaking, if only we learn to listen carefully enough. And this listening, this patient observation across decades, is itself a kind of human poetry. To study something that will outlast civilizations, to devote careers to the slow unfolding of a star's orbit, is to place trust in continuity, in the idea that knowledge can accumulate like light over time. Generations of astronomers contribute to the same grand story, handing down their measurements as though passing a torch through the centuries. The stars move, the data builds, and our picture of the hidden heart sharpens with every passing year. There is also a humbling intimacy in knowing that we are bound to the same dance. Though our orbit is vastly larger and slower, Earth too circles Sagittarius A star. Our sun, along with billions of others, is caught in the embrace of the galactic core. When we watch those stars whirl near the black hole, we are not merely studying something distant. We are seeing a reflection of our own path, the unseen influence that governs our place in the galaxy. The difference is scale, not essence. We too are notes in the same song. And so, when we say that the stars closest to Sagittarius A star carry its story, we might also say they carry ours. They are the visible sign of an invisible truth, that we live in a galaxy, not adrift, but structured, ordered, bound together by the gravity of a hidden giant. Every orbit is a reminder that chaos has form, that even in darkness there is pattern, and that within pattern there is meaning. Perhaps this is why watching these stars moves us beyond science into awe. It is not only that they confirm equations, but that they embody the profound harmony of existence. They tell us that the universe is legible, that even its greatest mysteries leave traces, echoes, footprints that we can follow. And in following them, we not only learn about Sagittarius A star, we learn about ourselves, about our desire to know, our patience to wait, our courage to seek meaning in the abyss. The stars sing their song, and we listen. They orbit in silence, and we find in their silence a story as vast as time. Their testimony is simple yet unshakable. There is something at the heart of the Milky Way, something massive, something unseen, something that shapes everything we know. They do not shout it, they simply live it, orbit after orbit, year after year, echoing a truth that cannot be ignored. And it is this echo, this song of gravity, that draws us onward. If the stars can reveal the hidden, what else might be waiting, just beyond the edge of our sight? What other truths lie folded into the fabric of space and time, waiting for us to listen? The song of Sagittarius A star leads us not to answers, but to questions, to the greatest question of all. There are moments in science when discovery feels less like opening a window and more like gazing into a mirror. To study a black hole is, in many ways, to study ourselves. Not because we are made of the same matter or share the same destiny, but because of what the act of looking reveals about who we are. Sagittarius A, the invisible giant at the heart of our galaxy, is one of those mirrors. When astronomers first pointed the Event Horizon telescope toward the galactic center, they were not only reaching across 26,000 light-years, they were also reaching inward into that quiet human hunger to know what lies beyond the veil. When the image finally emerged, a trembling orange halo wrapped around darkness. It was not only a portrait of a black hole, it was a portrait of our own curiosity, of our willingness to stitch together data from across the globe to glimpse something that cannot be seen directly. The shadow in the photograph is cosmic, but the awe it stirred is deeply human. To look at Sagittarius A is to see reflected our fear and wonder in equal measure. The fear is ancient. For as long as stories have been told, people have imagined abysses that swallow all who approach. Black holes are a scientific echo of those myths, made real in equations and telescopes. They embody the archetype of the devourer, the monster at the center of the labyrinth. Yet, in the same breath, they awaken wonder. For here is something that should terrify, yet instead it draws us closer, inviting us to understand. That tension between dread and desire is the reflection of our own nature, our impulse to step toward the unknown, even when it unsettles us. And in that sense, Sagittarius A becomes less a monster and more a teacher. It shows us limits. The event horizon is a boundary that cannot be crossed, a place where knowledge ends. Light, time, causality, all of it collapses into silence. No matter how advanced our tools, no matter how vast our imagination, there are truths we cannot recover from beyond that line. Yet even in telling us no, the black hole gives us something profound. It defines the edge of what can be known, and in doing so, it sharpens our sense of wonder about what lies just out of reach. The mirror reflects not only the cosmos, but the humility required to look at it. Think of what happens when we imagine crossing that horizon. Clocks slow, space stretches, reality bends. From the outside, the traveler never arrives. From the inside, the traveler passes through a threshold beyond all description. We cannot follow them, not with light, not with language. The black hole whispers there are boundaries in the universe, and beyond them lies silence. But in that silence, something is revealed about us. We are not satisfied with silence. We ask, we speculate, we build theories of information and quantum mechanics, desperate to know whether what falls in is lost forever or somehow preserved in a deeper order. The black hole becomes a mirror for our refusal to stop seeking, even when the void stares back. This mirror shows us our fragility, too. When we stand on Earth, looking toward the galactic core, we see a black hole that could, under different circumstances, disrupt stars, consume gas, unleash flares bright enough to ripple across thousands of light-years. Against such power, we are tiny, as fragile as dust motes in sunlight. And yet, the fact that we can even conceive of such forces, let alone measure and describe them, suggests a resilience of a different kind. Our strength is not in mass or gravity. Our strength is in curiosity, in imagination, in the simple fact that we dare to look up and wonder. Sagittarius A reflects this strength back at us. There is a paradox in this. The black hole is utterly indifferent to us. It does not care whether we study it or ignore it. Its gravity pulls the same either way. And yet, in our relationship to it, meaning emerges. We assign significance. We tell stories. We place ourselves in the frame. In this way, Sagittarius A becomes a teacher of perspective. It reminds us that meaning is not given by the universe, but made by us, in our attempt to interpret the darkness. The mirror shows us that our greatest gift is not only to observe, but to weave observation into understanding. Take a moment to let this thought settle. When you imagine the black hole at the center of the Milky Way, what you are really seeing is not only the abyss, you are also seeing the reflection of a species willing to peer into that abyss, to endure mystery rather than turn away from it. The darkness becomes less an enemy and more a companion, walking with us on the path of knowledge. And in this companionship, a transformation occurs. Black holes are no longer only destroyers, they are also creators of galaxies, of scientific revolutions, of awe. Sagittarius A is not merely a weight at the center of our galaxy. It is a weight at the center of our imagination, pulling us toward deeper questions. What is time? What is reality? Where does knowledge end? What lies beyond the boundaries of thought itself? These questions are not just physics. They are philosophy, poetry, prayer. They are the language of a species staring into the mirror of the cosmos and asking, who are we? In this way, Sagittarius A becomes not the monster in the labyrinth, but the labyrinth itself, a place where entering means transformation, where wandering its mysteries reveals something about the wanderer. It is not there to frighten us away, but to invite us closer, to show us that at the edges of understanding, we find ourselves reflected most clearly. And so, when we think of this black hole, we might think less of destruction and more of reflection, less of silence and more of dialogue. For in gazing at it, we are not only studying the universe, we are studying the part of ourselves that insists on listening, on looking, on asking, even when the answers are hidden. The abyss gazes back, not with menace, but with a quiet invitation. Come closer, seek more, discover who you are in the act of discovery itself. Which brings us full circle. We end where we began, at the heart of the galaxy, with a mystery wrapped in silence. A black hole that bends stars, shapes galaxies, and mirrors back to us the questions that define what it means to be human. It is not only the heart of the Milky Way, it is also, in a way, a reflection of our own heart, the restless, wondering heart that beats within every act of curiosity. And as we leave it now, drifting in thought, we carry that reflection with us. For Sagittarius A is not only out there, 26,000 light years away, it is also here in the stories we tell, in the questions we ask, in the courage to look at the darkness and find in it not emptiness, but a mirror. At the end of every journey, there comes a point of return. After wandering through light and shadow, through orbits and flares, through questions of time and eternity, we circle back to the beginning, to the place from which all paths seemed to radiate. At the heart of the Milky Way, hidden behind a veil of dust and silence, there lies Sagittarius A, the quiet heartbeat of our galaxy. Unlike the bright chaos of supernovae or the blazing fire of newborn stars, Sagittarius A does not draw attention to itself. It is an anchor, not a flare. Its gravity binds without display. Its silence holds without spectacle. And yet, without it, our galaxy would be something else entirely, scattered and unshaped, like sand slipping through fingers. The black hole is invisible, but its presence is undeniable. It is the unseen hand that guides the spiral arms, the steady center around which billions of stars turn, our sun included. To call it a heartbeat is not only metaphor. Just as the pulse of a living creature sustains the rhythm of its body, Sagittarius A sustains the rhythm of the Milky Way. Every orbit, every swirl of gas, every faint glow from the galactic center is a sign of its silent influence. We may not hear it, but the galaxy moves in time with its gravity, a vast celestial body kept whole by a single point of density. It is strange, almost contradictory, that so much structure, so much beauty, is governed by something that appears as nothing. But perhaps that is the lesson, that what we cannot see may be the most essential of all. And in this, humanity finds both insignificance and meaning. Insignificance, because when we place ourselves against the scale of a supermassive black hole, we are dust against a mountain, sparks against a storm. Our entire history, every life ever lived, unfolds far from the galactic center, unnoticed, unaffected in any direct way by this giant. It could flare, it could slumber, and our world would spin on, a fragile bubble of light around a small star, mostly unaware. But there is also meaning, profound and delicate, in knowing that we can look across such distance and glimpse the invisible. Our eyes and instruments, our mathematics and imagination, have allowed us to reach into the galaxy's core and touch the edges of what cannot be touched. To recognize the existence of Sagittarius A is to acknowledge not only the scale of the cosmos, but also the depth of human curiosity. The black hole may not care for us, but in studying it, we find ourselves. We find the desire to ask questions that stretch beyond survival, questions that look into the abyss and do not turn away. In its presence, we are reminded that mystery is not something to be feared, but embraced. For what is a galaxy without a center, and what is a life without questions? To exist is to circle around something larger, something unseen, whether it is a black hole in space or a truth within ourselves. Sagittarius A shows us that there is beauty in silence, power in invisibility, meaning in what cannot be grasped. Take a moment to imagine yourself drifting near it, suspended among stars. Around you, the galactic core blazes with light, but ahead there is only darkness. Not a hostile darkness, but a deep, quiet one, a darkness that listens. You feel its pull, steady and constant, and realize that the same pull has shaped the entire galaxy, threading order through chaos, holding together a cosmic family of suns and worlds. It is as if the black hole is not a monster at all, but a patient guardian, a reminder that even in silence, there is influence. And perhaps that is why we return here at the end. Not because the black hole has changed, but because we have. The journey has taken us through the evidence of orbiting stars, through the quiet hunger of flares, through the test of relativity, through the fleeting glimpse of its shadow, and finally through the reflections it casts upon us. Each step has been less about conquering mystery and more about dwelling within it. Now, in returning, we no longer see only absence. We see presence, subtle but immense. Sagittarius A is the heart of the Milky Way, but it is also a mirror for the heart within us. Both are invisible in their essence. Both sustain life in silence. Both beat with rhythms that are often unnoticed but never absent. To live in this galaxy is to be bound by that heart. To wonder about it is to be bound by our own. The two are not so separate as they seem. And now, as you picture the stars drifting slowly in your mind, imagine the spiral arms turning with unhurried grace. Each orbit a quiet testimony to the black hole at the center. The galaxy is vast, and you are small, but your thoughts are vast too. You can place yourself in that spiral, recognize your place in a story much larger, and still feel that the story is yours to carry. The abyss at the center does not diminish you. It expands you, reminding you that your awareness of it is itself a kind of light. We return then to the silent center, not with fear, not with despair, but with reverence. For in its quiet gravity lies the proof that absence can hold presence, that darkness can sustain form, that what cannot be seen can still shape destiny. The black hole does not need to roar to be powerful. It does not need to consume to matter. It simply is. And because it is, the Milky Way holds together. Because it is, we find ourselves orbiting, existing, wondering. And now, let us rest with this thought. At the heart of our galaxy, there beats a silence that holds everything. It has no voice, yet it speaks. It has no light, yet it guides. It is invisible, yet without it, there would be nothing to see at all. Close your eyes, let the image soften and drift with the stars. The spiral turns, the center waits, and all of it is wrapped in silence. The galaxy breathes, and so do you. The journey ends here, at the quiet heart, where presence and absence are one, and where mystery rests like a lullaby.